Hello children, welcome to channel Sube. Today I am going to discuss question number 48 from the MCQ part of 2019 Physics new syllabus paper. Two long straight and parallel wires are placed in free space. Consider the following two cases as shown in the figures. Case A, wires carry the same current I in the same direction. B, wires carry the same current I in opposite directions. Consider the direction of the magnetic flux density into the paper as positive. Which pair of graphs best represents the variation of the magnetic flux density B between the two wires? Let us try to solve this problem, children.
Hold a current-carrying conductor in your right hand such that the fingers wrap around the conductor and the thumb is stretched. Now, the right hand grip rule states that if the thumb points in the direction of the current, then the wrapped fingers will show the direction of circular magnetic field. Let's study Maxwell's corkscrew rule. The direction of the circular magnetic field around a current-carrying conductor may be found by visualizing a right-handed corkscrew being rotated so that the point of the corkscrew moves in the direction of the current. The rotation of the corkscrew is the same as the direction of the magnetic field.
So now let us focus our mind to the question. So now you know how to use your right hand to determine the direction of the magnetic field lines according to the current given. So here let us place our right hand so that the thumb is directed to the direction of current flow. So in this way, like this, the current flows upwards. So now you see these small fingers are curled like this, so that means the direction of flux lines like this, coming out of the paper, So we can draw now them like this, They are closer to each other at the places closer to the wire. So when they are going further away from the wire, they separate more than the lines closer to the wire. So like this. So the direction now we know like this out of the paper. So we don't have to check this side because in the graph that side represents this area, so they don't have used drawn the graph there. We need only the middle. So what is the direction of flux lines at the middle? So the flux lines come out of the paper like this and goes into the paper here. So we have to mark a cross. So the direction of flux lines at the center is like this into the paper. So let us mark it at the center. So like this into the paper. So we have to draw a cross, therefore, like this cross, because we see the back side of the arrow entering the paper or this screen perpendicular to the paper. So actually we see this one, but in 3 dimension we can do like this. So now let us check the flux line, direction of the flux lines of this right side wire, placing our right hand like this. The direction is like this, the current, the direction of the current. So flux lines then come out from the paper in this area, goes in to the paper in this area, because they rotate like this, spin, coming out and rotating and going into the paper like this as circles there. So now we can draw the lines very closer here, little by little, separate from each other, weakens when they go away from the wire, so like this. So now the direction we know, coming out from here, going in from here. So this side we don't want, because this area represents out of the graph. So we need only what's happening in the center. So direction is opposite and magnitudes are equal. Why? Because this distance from each wire is same, and the current also is same. Therefore the magnitudes must be same like this. So opposite direction, magnitude same. So resultant is 0. So this one is coming out, this one is red one is coming out. So we can draw a dot, because we see the point of the arrow. So resultant is 0. Therefore we have to choose only the graph A. Resultant is 0 at the center, correct? Resultant 0 at the center, correct? Resultant 0 at the center, correct? Resultant not 0 is a positive value, so wrong. Resultant is 0 at the center, so correct. So there are 1, 2, 3, 4 answers now are correct. So we have to do furthermore. So now let's go to the second diagram B. So the direction is same as A of this first wire. So easy, we can find like this the direction and goes inside here at the center. So let us draw the flux lines like this in 3D format. Like this, like this, like this. Enough. So center, what happens? Come out like this and goes in. Then you can draw at the center like this, an arrow going into the paper. So that means a crossing, cross like this. Then let's check the right side wire, this one. No, this one the current is opposite. We can't use this hand, the same right hand, but I have to use another picture, another image. The same right hand turned down, this one, turned down like this. So now you can see, because the direction of current is towards down, so you have to turn your thumb downwards. Still this one is right hand, right hand. So the fingers, you see, small fingers, turn this way, curled this way. So that means it is a cross. At this center region, the lines are going into the paper. So we see the back of the arrow. So we don't have to talk about this side because they have not drawn there. So now you see both the wires supply magnetic fields towards the paper like this, towards the paper. So they don't cancel each other since the magnitudes are same twice, because they add to each other. Then the final final flux density is 2 times as the flux density of a single wire given by a single wire. So that means it can't be 0. It is not 0 here, not equal to 0. So some positive, because flux density we have to take as positive, which way of graph space. Positive when they go in direction of the magnitude flux density into the paper as positive. Into the paper as positive, we have to take into the paper as positive. So this one into the paper, so positive, both positive. Final one also positive, therefore. So we have to select the second graph positive. So this one 0, wrong. Now total is wrong, this one 0, totally wrong. This one positive. Some height is there. This one then correct. So this one previously we have decided it is wrong. We don't have to check now. So this one 0. So wrong. Now we have finished. Previously we decided this one wrong, because this one, the mark is there, you can see here, previous mark is there, so it is wrong totally. This one now we decided wrong, because not positive. So finally, children, this one is the correct one, because it has a positive value in this B graph, positive value. So this one is correct. So the answer is fourth one. I think you understand. I think you are happy. So children, I will be happy if you subscribe my channel. So thank you very much for watching my videos. Watch them daily, again and again, frequently. Come to my channel and watch my videos. So see you tomorrow. Goodbye.